Bum 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 bum.
Tomatoes?
Hello, welcome to the video for using KeyState for bindable key input. Now, because this is a Don't Give a Wink Wednesday video, it's basically going to be a lot more free form. This is just me messing around with something, polishing up the product, and then putting it out for hopefully someone to learn something from. So let's go ahead and get started. So, in 4.11, a new node was added called KeyState, and basically, on demand, it will query a key and tell you the value of that key. If it's an access key, it's going to give you something like partial, 0.1, 0.2, whatever the access is, positive or negative, like on a mouse X. Or if it's an if it's a Boolean type key, like a keyboard, it'll give you 0 or 1 for on or off. Let me shut off that stupid lighting. I was doing that for testing. Okay. So what I did was I wanted to see if I could do my own bindable input key state. Something like Unity would check on your tick event, basically, what they call update, and you would check to see the status of a key. Up, down, in use, whatever you bound it to. And then based on that, during your tick or your update, you could react accordingly. Now, Unreal uses a input system in the project's input, and you map events. And what this will do, if it's an action or an axis, it's going to pull behind the scenes, and whenever something's changed, it's going to fire off the input event. The problem with that is that's defined at design time, not at runtime. So let me run this. I realized I probably should have shown this first, then people can skip if they don't want. This is what I have set up for my keybinds. If I was to move, I can move around. I can fire. It'll only fire once every time I push the button. I can hit Z to duck and let go. And it basically reacts like a normal input system. But it is set up here inside the game as a bindable system. I can click, for example, forward and rebind these to my arrow keys. And when I hit done, now you can't see it, but I'm using my arrow keys to move now instead of my WASD. And if you notice, it's actually saving them between each time. And if I was to rerun it, it's going to go ahead and save my keybinds between each gameplay. So I tried to create something. I wanted to see if I could do that first of all. And just to summarize it, it works basically. And it works with a single key input. And I can kind of mimic the axis inputs, such as your arrows, maybe your up, down. I'm not mimicking things like the mouse X and Y. I can mimic pressed and released if, for example, you want something to only fire or unfire, like our fire button in this case, or jumping, or our ducking. But things like multiple keys, control left mouse to fire, for example, or control alt W for a hotkey. I spent 2 days trying to get those working. It's a giant pain in the ass, and I basically rolled everything back to this state and just left it as is. This is good maybe for a game jam or a simple game where you want to allow one key for input and allow your player to rebind them. Maybe as a nice customizable template or prototype you want to send out. If you want a full, robust, rebindable keybind system, you're going to have to do it in C++ right now as part of a source modification, and it's actually a ton easier. So let's just, now that I've spent 4 minutes babbling about what this does and why I did it, let's roll through the meat of this. So, and I say so a lot, I've realized. How this works is we have a keybind UI that you set up once and you assign inputs to, and then we have the actual character itself, who this will look familiar if you've used inputs. Basically, we have an input and then an action, an input and an action. This is normal. But the way this system works is basically every tick, it's going to roll through all of our different inputs, check to see the status of the key using the key state, do something appropriately. In this case, I'm calling our internal events. And then it's going to repeat. And it's going to do that every frame. Now, through profiling, if you're using this system or you're using the Unreal Engine input system, they're going to perform roughly the same. I didn't really see a perceptible difference. And in the profiling, you're either going to use the character movement input tick, or you're going to use my event tick, one or the other, because it's still going to check frame, as far as I know, pretty much frame by frame, or tick by tick, if you have any input it needs to process. So it's still going to be an overhead even if you use the Unreal Engine version. So let's get started with the basics. Let's close down everything but our event graph. Okay, so first caveat. The event system, the KeyState, runs off the player controller. However, for whatever reason, if you do an event tick and then you try to do something to the character movement component, if this event tick is inside of your controller and you're trying to tell your controller to do something, traditionally you have your controller. Your inputs may be in your controller, and then you give them to your character, your player, your pawn. Your character movement will then absorb that input and then do something appropriately. Turn, move forward. Now, usually when you're using an input system, the input events that I've showed earlier, it's not an issue. But I found for whatever reason, if you're doing that on a tick, if for example this tick said to move forward or move right or do an input event like down here and add movement input, if the controller is ticking and sends it to the character, it disappears. It literally never shows up properly. The values are sent, but the character movement ignores it. Whether the controller tick is after the character, maybe in the process, and it ends up getting erased, I don't know. I never really figured it out. But basically, in order for the event tick to do things to the character movement, that event tick needs to be inside of the character itself. Just a bug. It's the reason why I had to put this into the character instead of the controller itself. Just gonna run through all the stupid issues I had. So how this is working is our tick on our character. We tick. Then I'm running it through a sequence because it makes it look, it's a hell of a lot easier to keep things organized. Let's say our first one is up here. Now I run through a macro called check key state axis. This macro takes in the index of the key I'm checking and then outputs a value. Our value in our state is going to be 0 to 1 based on this key, and I'm going to fire off my input forward. Basically, we have an input array, which is set up with 7 elements, which are bound to nothing right now. And each element internally is a key. Value 0 is going to be my forward key. Value 1 is going to be my backwards key. Value 2 is going to be my left key. And it's going to repeat down, all the way down. So let me get rid of crouch. Let me reduce this down to 6. I'm basically going to remove crouch. And then as I go through this, I'll walk through how I set up a crouch. We'll get rid of this. And let's go into our keybind menu. Let's get rid of crouch here. Probably should have done this first, but I want to show everything working. And then our event graph. Let's find it down here. We don't have a crouch button anymore, so we need to get rid of that. And for the most part, that's going to be all we need to do. And I'll show you why and how we're going to end up using this in a second. So, back to our character, since I got sidetracked. Up here, we run it through one of our macros, and our macro does something. Let's walk through how you would set it up and then the background. Let's assume maybe you want to copy this project and use it for your own, and you don't want the background portion of it. What you're going to need to do is you're going to need to make sure your sequence, let's remove the last one, there we go. Your sequence can fire off your event. We're adding a new event. We're going to make our character crouch, so let's add a new pin. Now, in order for the new pin to work, let's drag it down to here conveniently. We need to check either the action or the axis. I have 2 macros created, action and axis. Now, basically, they're meant to kind of mimic the axis and action events inputs that we already have. Action is going to fire off, pressed or released, and it's only going to fire one and only one, and it will not repeat. KeyState axis is going to fire off every single time and return back a value. This is useful for a button like jumping or firing, where you want to know if it's pressed or released. This is useful for something where you want to monitor the input continuously, like maybe your WASD for movement. In this case, we're going to use this one. We want to check if they jumped or not. Now, you'll notice over here, I check and then I fire off an event. Now, you don't have to do that. I did that to keep things clean. This you could think of as identical. I'm going to have to do this. Let's do a new action. No, we'll call this one crouch button. We don't have to bind it to, we'll bind it to, I'm just going to delete this in a second. We'll just bind it to the 0 key. So traditionally, you would do crouch button, and you'd have input out action crouch button, and you have pressed and released, and the key. So you notice I have them pretty similar. And normally you would have this, and then maybe for crouching we would do crouch, and then we would do uncrouch, uncrouch. And that's it. And basically whenever this input comes in, we fire off crouch, and when we let go of it, we fire off pressed, released, and it never continuously fires them. It's a cycle, on or off. You can do the same thing with this macro. It's designed to allow you to basically mimic. Or you could always have your own custom event down here and do the same thing. I separated them down here just to make it cleaner. As you can see, if you had all of these things over here, it might make this a little cluttered for your actual sequence. But you can obviously do whatever you want. So in this case, we're going to check if this key was pressed or released, and if so, fire crouch or uncrouched. Well, what key? Let's figure out what our last index is. Our last index was 5, so let's add a new one. We're going to call this index 6. Now we need to make sure we have 6 indexes. In this case, we need to add one. So now we have 0 through 6. And we need to make sure our state array has 0 through 6. So now we can successfully store the state of the button and the button itself. Now if we go into our Keybind UI, we need to set up a button for it. We only have 0, 1, 2, 3, 4, and 5. The nice thing is, this is pretty simple. We'll copy and paste in a new one. Call this one crouch. Then we'll copy and paste our button. And we'll call the button... Oh, this really doesn't matter. The button text, that was changed recently. So we'll change this one to button crouch. Yeah, you don't actually need this button text anymore. That's all changed. But what matters is the key index. If you notice, we have key index over here of 0, 1, 2, all the way down to 5, and then we need to make sure our crouch is set to 6. So now our button, when we use it, is going to bind key index 6. Down here we need something for our button to do, so we just want to bind a new event to it. And this one's pretty simple. We have handle button being clicked. And we hook it up. Our button reference goes to button clicked. Our key index goes to key index. And that's going to be it. That's actually it. If we were to go ahead and run this, we'll now find we have crouch down here. Now I've already saved it. That's why it's showing up. But normally it'll show up as blank. And now we can actually click on crouch. And let's say we rebind it to our N key. Hit done. And my N key is now crouching. And that's all you would need to do to make new ones. If you wanted a new one, let's say for interact, you'd make sure you duplicate this portion. You would make sure you have a new setup in here for an interact button. You'd make sure your key index would be 7 in this case if we're adding. And you'd make sure that in here you have something checking for an interact button, probably an action with index of 7. And make sure you're actually doing something with it. And make sure you have a state array with a 7th index and an input array with a 7th index. And that's all you need to do, and then it would work properly. Then basically you'd have this running and then do whatever you want for interaction. So how does this all work? Well, it all revolves around the lovely macros I've created here for the action and the access. Let's go ahead and do the access. It's one's so much simpler. Basically, comes in, checks our index, gets the key assigned to that index. So in this case, WASD for movement. So let's say we're talking about movement. Let's say it's our first index. So it's W. It gets key W. Gets the state of the W key and then passes it back out. Since we want this done every frame and we don't want to toggle it, that's all it does. And all this is doing is basically getting the state of our W key and passing it to forward. And then our forward event is simply working just like a key input. It's adding that scale to our forward direction on the pawn movement input. So it's really simple. The complex one is going to be our action. This is where I learned local variables and macros, and I learned they are a giant pain in the giant ass. So we take our input with our index. Nothing different here. What we're doing here is using what's called a local variable, which you can use inside of macros. If you notice, our macros down here don't have a section for local variables like functions. That's because macros basically create a temporary variable that is only used during the execution and then is removed afterwards, but it's not actually stored anywhere for reference. It's stored kind of like it's literally temporary. You say local integer creation. So let's say I wanted a local bool. I would do local bool. And this would create a local boolean. Now here's the catch. This node is my local boolean. If I was to go local boolean again, this is a completely separate node and a completely separate variable. This is where the gotcha comes in. This is technically, var1, and this one is technically, assuming I can copy, var2. These are completely different. If you want the value of this, you need to pull off of it into every single spot you want it. Which is why when you see here, where this is labeled key index, this variable is used in 4 different places. And I have to pull off of that entire one, which is why you notice our nice little clean spaghetti work here, because I had to use that same node in multiple places. And you can see here, I had to use the same node in multiple places. You can't make local variables and then stick them in where you want them. So, in addition to that, to set a local integer, you just don't set it. You actually assign it using the assign node that takes in the variable you're setting and then the value. Now that that's all out of the way, basically we are assigning the value of our index to a local integer. We are assigning the value of our input state array to a local boolean. What this is doing is, when we get into our macro, we're saying, okay, what is the state of this button the last time we set it? The state being 0 or false for not activated or not pressed, or 1 for being pressed. This lets us know the last time we were through here, was this button pressed or not, because we want to only fire it if it's changed. So it lets us know what the last state is. We go ahead and we set now that we have the last state, we don't have to worry about it anymore. We've stored the last state. Now we go ahead and set the current state to our array. So let's say we came in here and we've just now pushed our button. And our button is W, which is index 0. We're going to assign index 0. We're going to assign the last state, which would be false. We've never pushed this button before. We're pressing it now, which means the last state was unpressed. Now we're setting the current state to pressed, and then we're going to go ahead and compare. We're going to go ahead and get the state of the button, like I said, and store it, and then we're going to see if it's changed. We're going to compare, are you currently pressed compared to were you currently pressed? In this case, it's going to come back as true because we're doing a not equal. So are these two not the same? Have we changed? That's why if you notice, if we read through here, what's the state of this key? Is the key state more than nothing? That means it's been pressed. Have we changed? Action event changed, true or false. Let's go and do this. Did we change? True or false. If we did change, did we press it or release it? And that's all based on if it's a 0 or 1 here on our key state. If we pressed it, we fire off pressed. We don't need that there. And if we didn't press it, we fire off released. This is one thing that's nice and why I did it in a macro format. If you have it in a function, which I don't have any functions I can pull out of there. Maybe I have one in here. Oh, yeah, here we go. In your function, you only have one input wire and one output wire. While you can have multiple return nodes, it's still only going to fire off one output. Macros have multiple outputs, which is why when we're looking in our event graph at our key state, we have a pressed and a released. And with the way this is hooked up, If it's been pressed, only true will fire, which means pressed. And if it's been released, only false will fire, or released. So it allows us to mimic our little input action. So only if the key has been changed, and only if it's pressed, will this wire execute. Only if it's been changed and released, will this wire execute. It's pretty simple. You can walk through it and hopefully you don't have too much issues. Now, in terms of the actual binding of the keys, because if you notice this right here, this is technically the hard work. This is it. These little macros right here are checking the key state every time you want them to fire, checking the key you've sent in based on your array that you've set up, and then determining if it should fire pressed or released, or if it should just fire off every time and give you a value. That's it. So our second hard part is going to be binding our keys properly. This one took a little bit of work. So in order to get this to work, we can ignore the closing, we can ignore the startup, because this is doing our keybinds. And what we care about is the actual button being clicked event. Now if you notice in here, we have a bunch of different functions, and what we're doing is allowing the person to click a button, capturing the next time a button or a mouse is pressed, determining if that mouse or button has been used before to prevent duplications, and if it has, alerting them. If it has not, binding it to the new value, and then refreshing our screen. So let's walk through that. So when we're looking at this, we have our values here. They can click, it'll ask them for the new key, it'll listen for the key, I push the key, and then it go ahead and binds it. Now if I was to do that with an existing key, down in this case, it's going to tell me there's an error, and it's going to prevent it from saving. I need to click again and change it to a valid value. So we handle the button being clicked here. We're capturing the button that was pressed, which is why when the button is clicked, we have a key index. This is letting us know which index we care about, because the index in here is going to be mapped to the index in here for our input array. So that way our input array and our keybind menu are kept in sync. So we now know which index is being bound, and we set a boolean for listening. We're now going to listen and intercept any input. And then we're setting the button to rebind as a local variable as well. That way we know which button we're changing, so we know which button when we're walking through to change to red or green and change the text on. We're getting that child. Now we're setting our text to new key question mark and then binding it to green, and then setting the visibility for our press a key mouse button. This is all user interface stuff. This is obviously customized to however you want it. This is what I decided to do. And then we're returning. And that's it. At this point in time, if you noticed, there's no other code running. Well, there's no other code running because we've set a is listening bool here, and basically we're now going to steal whenever the person pushes a key or a mouse down. We're going to intercept, and if you know, by the way, this extra was due to me trying to implement multi-keys. That's how much extra I had in there trying to handle multi-keys. And this, now that I can resize it back down, is what I actually have. So, on key down and on preview mouse button down. Basically, when a key is down, it's going to fire this event and something's going to happen. Or if a mouse button is pushed, it's going to fire this mouse button event, which is identical, and something's going to happen. What do? Well, are we listening? We only want to intercept a key if we're actually listening. If we're not listening, then we do nothing. If we are listening, we store the local key, so that way we know it's called local key and we can use it for later. We want to keep things tidy. So we're storing the key we just pressed. We're firing off a function to check and see if that key's been used already. I'll cover that shortly. If the key was used, we are handling the duplicate key being bound. We're giving them an error and we're preventing it from saving. If it has not been used, if it's a unique key, we're going to go ahead and save that unique key to our input array. Now if you notice here, I have a macro, and a function to keep these things organized. Plus, like I said, The preview mouse down is pretty much identical, except I'm actually getting the button rather than the key. So that's the only part that's really changed. The rest of this part here, duplicate key, checking, duplicate key, save new key, is the same. Duplicate key, checking, duplicate key, save new key. So macros and functions save me all that time from rewriting code. So let's go and run through what's happening. So duplicate key. This one is simple now. Very, very complicated if you're using multiple keys. So that's another thing to think about. That's why I recommend only using this for very simple stuff. Which key are we checking? Does our input array contain this key already? If it does, you'd think, well, we don't want to bind. But there is a small catch. If you're rebinding the same key over itself, you don't want to give them an error. So what this is doing is checking for, again, does that key exist inside of our array already? And is that key that we're rebinding the same one that we're rebinding? So for that, I mean W, and I push W again. That's rebinding the same key. If we did not do that second check, it's going to go through and it's going to be like, well, yeah, your array contains W already, and it's going to fail out. See, the nice thing is, boop, we'll do that. We'll run through this. We'll do W, and you notice I have an error. Technically, that's not a duplicate key. We're just rebinding the same key to itself. So, I had to do a little bit of error checking there. And then now you'll notice when we rebind the same key to itself, it works fine. So that's what that does, for example. And then we're just setting whether or not it's true or false. Did we find a duplicate key, yes or no? And if so, we are setting it as duplicate. And because that's a nice little function, we're passing it through to our if branch, and then we're doing something. So let's see if what we do here. Is it a duplicate key? We'll run through this little macro here. We stop listening for a new key. I tried a few different ways of having it continually allow you to, if you fail input, to listen continually for new input till you got it right. But in terms of user experience, it's a little bit confusing because you might click to rebind, you might push a button that's already been used, and it's going to alert you that's already been used. And then you're going to think, okay, well, I need to rebind it again then. But the next time you push a button, like to click to rebind, it now uses the left mouse button as the key you want because it's still listening for input. So this one's one of those user experience things. Stop listening. Tell them which key has already been bound. Give them our error text, and then show our error text. That's all this does. In here, if we didn't error out, we're saving the new key. And this one's super simple. Which key did we press? Store this for later. Stop listening. Get our input array. This is our input array. This is a little macro for handy use. Basically, player character, cast, get the input array, and then return the input array. So get our input array from our character, set an element on it, that is our index, to the new key. So that's all we're doing here, is basically taking that input array and setting what key we want it to be, refreshing our keybinds, and then finishing. Refresh keybinds is pretty... Did I duplicate that, actually? Yes, that is so funny. Okay, so in here, saving our keys, I'm refreshing our keybinds. And then right after that, on the key down... wait, where was it at? Did I just break that again? Let's see, save new key. Oh, what did I just do? No, I thought okay, never mind. Save new key. Nope, that should have been there. Apparently my brain stopped working. Okay, so set the element in our array and then refresh keybinds. Refresh keybinds basically gets all of our widgets, takes the value of each widget, which is our keybind number, remember, right here, our key index, makes a new temporary array, organized in the order that we have our key indexes. That's important. So that way all of these buttons right here will be 0, 1, 2, 3, 4, 5, and 6. Figuring out which key is assigned to each one, setting that value on the screen, hiding any of our error texts, and then returning back. Let's close everything else and go back to here. And we want our key down, and we're back to here. And that's it. And that's what is going to happen there. So we've saved our new key because it's valid, and we returned, and we've gone ahead and refreshed. Which is why when I do this, waits for input, pushes the button, it's a duplicate, I click it again, assign it to the new one, saves it properly, saves it in my player, and now I can move. And I unbound those ones. There we go. So now I can move again properly. And that's pretty much going to be it. Now, the extra two things I'm not going to cover. These were just nice convenience features I threw in. You can feel free to pick them apart. These are going to be our saving and loading of keybinds. These are really, really simple. Basically, when I construct our widget, I am loading up any existing keybinds and then refreshing the screen. Load keybinds is very simple. Getting our save game. If a save game exists, then we're going to go ahead and set up our input array to the keybinds we pulled out of our save game. Saving is pretty much the same thing. We're going to create a save game object, see if it exists. If it doesn't exist, create a save game object, no matter what, and try this again. Create a save game object, because you always need a save game object. Cast it to our custom save game. Set our saved input keys variable inside the save game to the saved input keys, which is on our player. And then go ahead and save that physically to our disk or our device. Like I said, those are two pretty simple things, and all I'm doing is loading it, and then on the done key down here. And then when I do the done key, when I close the window, I'm simply saving them out. So when this loads up, it loads it from save. This is saving it to the player. Every time I do this, it's saving it to the player's character. When I click done, it's saving it to disk, and now I can move. When I hit the menu, it loads it up from the save game, and it continues on. So that's going to wrap this up. I know it was a lot of jabberish, but hopefully you got some information from there. The source code is in the link below. Feel free to copy it, use it for whatever you want. I do not intend on expanding this. This part here took me a little bit more than a day. I'd say maybe 5 or so hours of work to get it functional, cleaned up, key binding, duplication, all of the basic stuff. Then I spent about another 3 days, a couple hours a day, trying to add in multiple key bindings. It is a giant pain in the rear because of edge cases. For example, let's say someone pushes the Alt key, and that is, well, here's an example. Oops, that's a comment. I'm not actually running the game. So, one thing you can do here is you can use, like, for example, left control for crouch, or Alt for crouch. Let's say someone has crouch set to Alt. Let's say someone has forward set to 1. Just bear with me here. I know that's not right, but bear with me. Now, let's say I wanted shoot to be Alt 1. So I'd bind the Alt and the 1 key to my shoot. Now, here comes the problem. I have crouch bound to Alt, forward bound to 1, shoot bound to Alt 1. When I press the Alt key, you would assume it would crouch. Now, if I'm holding down the Alt key and I push the 1 key, do I fire off shoot, which is bound to Alt 1? Do I fire off forward, which is bound to 1? Or do I fire them both off? That's one of those edge cases where I tried to cover and I decided it wasn't worth it. Something like that is better handled inside of C++. Basically by taking your existing inputs, setting up your existing inputs, kind of like how I did in here, where you have your different types, and then using C++, exposing the ability to rebind this key value to this input. That way either you are using the existing input system that was designed, but giving it the ability to keybind. And if that's a little complicated for you, as of right now in 4.11, they do not have it exposed. Maybe they will in the future. If not, there are plugins in the marketplace that can do this. There are plugins that work with C++, in the marketplace soon that will be able to do this. And Rama on the Unreal Engine forums has released a free plugin that can also do blueprint key rebinding as well. So there are other alternatives. The goal of this project was to learn the new KeyState, see if this was possible, and then see if I could actually turn it into something useful. And as you can see, it's useful. If I want to make a game jam game, for example, and I want to allow my players really quickly to rebind basic keys, I could do that. I mean, this is a first-person shooter. I add an interact button, and I have the basics of a first-person shooter here, and I can give the ability to allow someone maybe on a different keyboard setup to do something like that. Or, and this is what's really nice, what if you're making a multiplayer game that allows 2 keyboard input? Some keyboards don't have your arrow keys, especially on like laptops, or they're bound funnily. You might want to allow a player 1 and a player 2 input, and player 1 can be over here on the left with WSAD, and then player 2 can be on the right with our IKJL. Yeah, there we go, IKJL. So you could allow 2 people and then customize your controls. So it's just meant to be a quick little fun little project. Hopefully someone learned something from this. If you did, leave a comment below. If you've got any questions, leave a question below. Feel free to check out the source code, do whatever you want with this. It's just intended to be fun. I will not be expanding on this anymore. This was a learning project that I'm passing along and sharing.